Yeah, so we're going to look at IP version 6 for this particular lecture. Essentially, it's the same logical type of address that IPv4 is. However, the layout of the address is very, very different. The amount of data it contains also very different. So let's go ahead and look at IPv6. Okay, IPv6 is a logical address, but it is a 128-bit number instead of just 32 bits. That means it can hold 128 bits or zeros and ones, binary digits, as opposed to only 32 binary digits. It works essentially the same. An IPv6 address uniquely identifies a network device. There are 2 to the 128th power available addresses as compared to 2 to the 32nd power in IPv4. And the Internet Engineering Task Force, or IETF, designed IPv6 to alleviate the problems that IPv4 was facing, mainly the shortage of numbers. 2 parts. A network component, just like the IPv4. In IPv6, it's the first 64 bits or the first 64 binary digits. A network component is used for routing, and it identifies the network. Basically, everything on the network has to have the same network component. A prefix linked or a prefix is the first 48 bits. The prefix describes the public topology, and then a subnet ID is the last 16 bits of the network component. Now remember, we're still within the first 64 bits here. So the first 48 is a prefix, and then the last 16 is a subnet ID. The subnet ID describes the private topology just like a subnet mask for an IPv4. Basically the site mapping or topology or pattern. A node component, that's the last 64 bits. This is the host component in IPv4. It has to be unique in order to identify a device on a network. So the network component has to be the same like IPv4, and the node component has to be unique just like IPv4. You got a activity here to do. Participation activities, make sure you get those done. IPv6 display rules. The rules for displaying an IPv6 address. Number 1, leading zeros are removed. So if there are any zeros as first character, they are removed from each hexadecimal group. That means you've got a group of 4 hex characters. And if any of those characters are 0, then they're removed. 2 or more hex groups containing all zeros can be replaced with double quotes. So if you've got 0000, you can use a double quote and get rid of that group. Just shortens down the length of the address. Rule 2 can only be executed once per address. So you can remove groups of zeros, but you can only do it one time per each address. And then a hexadecimal group containing all zeros can be also replaced by a single 0. So this rule is explained, or these rules are explained in the condensing participation activity. Make sure you get this one done. Matching the IP term to the definition, participation activities, make sure you get those done. Supported address types. There are 3 types supported in IPv6. Number 1, a unicast. That is a logical identifier representing a single network device. It sends IP packets to a single destination. Multicast is a single device that sends IP packets to multiple destinations. You can stream packets to multiple clients. An anycast is an address assigned to multiple network interfaces. So an anycast transmission sends packets one device in the group, usually the closest interface containing an anycast address. Transmissions are usually used by servers in content delivery network or content distribution networks. A content delivery network is a geographically distributed group of servers. A broadcast address is a single IPv4 used to send data to all devices on a network. Broadcast transmission sends IP packet data to all devices simultaneously. Broadcast causes excessive traffic. You don't really want to use it, leading to collisions and network slowdowns. IPv6 does not support broadcasting. It kind of works around it using multicast and anycast, but it does not support broadcast. It does not send out blasts of packets to all the devices at the same time. Another participation activity, make sure you get these done. Advantages and differences for IPv4, V4 and V6 address is different in the concept of public and private. A P4 IPv4 private address and a public address is a predetermined range. That means there are only specific addresses that are publicly routable and specific addresses that you should use privately. Private address is not a member of a public range. If you recall a while ago, there are places in the private range, or in the public range rather, where there are gaps, and those were the private addresses. On the other hand, an IPv6 address is accessible by outside networks, such as the internet. So a public IPv6 address is globally unique and assigned to web servers, mail servers, and other servers directly. A private IPv6 address used in private local networks, just like a private P4 or IPv4 address, it is never routed outside the local network. Whether it is public or private is determined by whether the IPv6 is located inside or outside of a private or public network, not by a public range. It doesn't have a designated range. Private addresses and public addresses, if you look at them from a numerical standpoint, they look the same. It just matters where they are located. IPv6 private address is going to be inside a private LAN regardless. But if you looked at it, it would look just like a public address. IPv6 allows aggregation of networks prefixes into a single prefix and announces this one prefix to outside IPv6 internet. So V6 reduces the size of routing tables, creating more efficient and hierarchical routing. V6 can auto-configure when connected to other V6 devices. IP address assignments and device numbering are two configuration tasks that V6 can carry out that V4 cannot. So here's a table of differences. You need to be aware of them. Another participation activity and a challenge activity. At that point, you will have completed this section and you can move on to the next thing. If you have any questions about IPv6, please contact me via the Canvas inbox. Let me know, or meet me in class, and I will do my best to answer your questions. Have a good day.